This is the real Tom Rose, and we're trying to figure out which function in algebraic terms matches the image that we've been given, right? And this type of function is called a hyperbola. You don't need to know that. If you did know that, and you know that hyperbolas have the equation something along the lines of k times 1 over x, then you could go right to the answer choice. But let's assume that you didn't know that, and let's assume that you want to have the capabilities of being able to match up functions and equations on the test without knowing what they're called or having information a priori, right? So one way that you can do that is plugging in numbers. So let's plug in some numbers to this top one. Let's just go down the list, and we'll try to see if we can rule out various answer choices. So for example, y equals 1 over 1 over x squared. So if we plug in, let's plug in a positive number, such as 1. Right? We're looking for, if we plug in a 1, I'm looking for something on the order of like 2. Right? It doesn't have to be exactly right, but suppose that I do that. We at least know it's positive for sure. If I plug a 1 in here, what I get is y equals 1 over 1. 1 squared is 1. So this would be, if I plug here's a point that's on this plot, 1, 1. Well, that's actually pretty close. Maybe I'm misinterpreting this chart, and maybe that kind of works. But let's see what happens if I put in a negative number. Suppose I put in negative 1. Negative 1 squared is 1. So 1 over negative 1 squared is also 1. So is the point negative 1, 1 on this chart? It's definitely not on that function. So this answer is out. Right? Now let's do the same thing with y equals 2x squared. Right? Let's plug in 1. If we put in 1, we get the point 2. That looks good. If I put in the point negative 1, however, I also get the point 2. That doesn't work for us because, again, that's negative 1, 2. It's in the second quadrant, so we can get rid of that. This next chart is the most promising, right? This one. If I put in a point such as 1, I end up with 2. If I put in a negative number, however, so if I put in a negative 1, I get 2 over negative 1, which is negative 2. So not only does that put us in the right quadrant, right, negative 1, negative 2. Let me put this in a different color since it's looking like it'll be the right one. So we'll do this in red. So 1, 2 looks like it's in the right quadrant, and negative 1, negative 2 looks like it's in the right quadrant. Not only are they in the right quadrant, but see how they're opposites of each other? Whatever number I put in for the x-coordinate, I get a symmetrical number on the y, but it's just negative. Well, that's kind of what this chart is doing, right? It's like whatever I have up here, I want roughly the same thing down there. So this is feeling really good. If I were on the test, I would probably just pick that right now. Let's look at some of these other ones. The log is the most annoying. Let's come back to that. The last one is the exponential, so 10 to the x. This will always be positive, and you can try plugging in. So 1 will give you a 10, which is already kind of way too steep. That's like up here. But if we plug in a negative 1, 10 to the negative 1 is just 1 over 10, which is a positive number. It's super small, but it's positive. And with exponentials, exponentials look like this. There is no place where they end up negative. So this is out. Now, logs. What does a graph of a log look like? So the graph of a log, remember that this is the same as the relationship x equals 10 to the y. So for each value, right, so I'm just using the definition of log to translate this. These are the same representations. It's for any given value of x, what does the power have to be on a 10 in order to give you that? So when x is 1, for example, what power of 10 gives you a 1? Well, it's actually 10 to the 0 that gives you that. So, 10 to the 0 equals 1. So when x is 1, y is 0. You can already see, even with that 1 point, that log is not going to be the answer. Right? So that's enough for our purposes. Just like FYI, the function of a log looks something like this.